In this lesson, we're going to be looking at a scope in JavaScript. What are scopes? An important idea in programming is a scope. A scope defines where variable can be accessed or referenced. While some variable can be accessed from anywhere within a program, other variable may only be available in a specific context. Over the next few exercises, we'll explore how a scope relates to variable and learn best practices for variable declaration. A block of code could be a function like this. Let's create a block of code. Inside the code, const log sky color as a function. Let color blue, console.log blue. This function defines a scope, and every variable in this scope are private only to this function. So outside of function scope, you can't access the color variable. So if you print this, you get this error. Color is not defined because color is defined inside this scope, I mean log sky color function, and it's unavailable outside this scope, so it returns not defined in the console. Also, you can define a scope with if-else statement. Let's say here we define if color equal to dusk, const msg it's too bad. Console.log msg. Let's change the const to let because it respect the blocks. So in this block, I mean the if block, we define msg variable which is scoped only to this block. So outside this block, you can't access msg. Let's comment this line and call log to sky function and see the result. You see, oops, sorry, here we need to change this line. You see, reference error, msg is not defined. You see, inside the if block we defined msg, but outside this we accessed the msg and it gives error in the console. Msg is not defined. Exercise. Exercise. Declare a const variable named city set equal to New York City. This variable will exist outside of the block. Great. Set. Let's get rid of this code. and define a constant city and set it equal to New York City. Below the city variable, write a function named LuxCitySkyName. Let's define another const with arrow function. So here we have LuxCitySkyline function. Inside of the function body of LuxCitySkyName, write another variable using let named skyscraper and set it to Empire State Building. So here I use let to define skyscraper and set it to this literal string. Nice. Inside the function, include a return statement like this. Let's return the stars over the skyscraper in city. You see, when you click in it, you know what will be replaced in the output, and when you press escape, you will see how will replace in the output. Beneath the LuxCitySkyline function, use console.log to log the value of LuxCitySkyline to the console. Great. Use console.log, and inside that call LuxCitySkyline function. Save and check the result. The result is the star over the Empire State Building in New York City. So we access the city variable, which defined outside the LuxCity function, which is global to this block, and we can access it through block. But if we wanted to access a skyscraper, what do you expect? Let's refresh, and you see skyscraper is not defined because it's only visible inside the LuxCity function, and it's not accessible outside the function block. Global scope. Scope in the context in which our variable are declared. Scope is the context in which our variable are declared. We think about scope in the relation to blocks because variable can exist either outside or within this block. In global scope, variables are declared outside of block. These variables are called global variables because global variables are not bound inside a block. They can be accessed by any code in the program, including code in blocks. Let's take a look at an example of global scope. Let's just copy this code and get rid of this code, replace it. You see, we declared constant color, and inside return a sky color function, we used color, which is a global scope variable. So we expected blue in the console, you see. Even though the color variable is defined outside of the block, it can be accessed in the function block, giving it global scope. In turn, color can be accessed within the return sky color function block. Let's work with global variable to see how data can be accessible from any place within a program. Write three global variables. Name the first variable satellite and set it to the moon. Const satellite moon. Name the second variable galaxy and set it to the Milky Way. The Milky Way. Name the third variable stars and set it to North Star. Great. You have defined three variables here. Below the variables created in the previous step, write a function named call my night sky. Inside the function, include a return statement like this. Great. Const call my night sky, and inside that return this one, and beneath the call my night sky function to use console.log to log the value of call my night sky to the console. Here use console.log, and inside that call it, then refresh the page. You see night sky, moon, North Star, and the Milky Way. You'll notice that the function block of call my night sky is able to access the global variable freely since the variables are available to all lines of code in the file. Block scope. The next context we'll cover in block scope is block scope. When a variable is defined inside a block, it's only accessible to the code within the curly braces. We say that variables has block scope because it's only access to the lines of code within that block. Variables that are declared within block scope are known as a local variable because they are only available to the code that is part of the same block. Block scope works like this. Let's get rid of this code and replace it with this one. Here we have a function called lock sky color, and inside that we define color with let keyword, and here we want to access the color outside of the block. It gives a reference error, but if we use it inside the block, it's okay. Solve this exercise by yourself, and it shows how you can use variable inside block and how it gives you error outside the block if you use that variable. Scope pollution. It may seem like a great idea to always make your variable accessible, but having too many global variables can cause problem in a program. When you declare global variable, they go to the global namespace. The global namespace allows the variable to be accessible from anywhere in the program. These variables remain there until the program finishes, which means our global namespace can fill up really quickly. Scope pollution is when we have too many global variables that exist in the global namespace, or when we reuse variables across different scopes. Scope pollution makes it difficult to keep track of our different variables and sets us up for a potential accidents. For example, globally scoped variables can collide with other variables that are more locally scoped, causing unexpected behavior in the code. Let's look at an example of scope pollution in practice so we know how to avoid it. Let's have this code here. Here we defined non-variable as a global, and inside the logNum function we change the value of this variable to 100 and log it into the console. Here, if we run this program, we see 100 in the console, but here if we want to access to num again, what happened to the num? Is it 50 or is it 100? Let's check the result. You see the changing value inside this function changed the value of variable in global escape, and it makes your program to be unexpected and lead to scope pollution. Exercise. What happens if we create a variable that overrides a global variable? Do this exercise by yourself and check the result to find out why it's not a good practice to define too many global variables. Practice good scoping. Given the challenges with global variables and scope pollution, we should follow best practices for scoping our variable as tightly as possible using block scope. Tightly scoping your variable will greatly improve your code in several ways. First, it will make your code more legible since the block will organize your code into discrete sections. Second, it makes your code more understandable since it clarifies which variables are associated with different parts of program rather than having to keep track of them line after line. Third, it's easier to maintain your code since your code will be modular. Fourth, it will save memory in your code because it will cease to exist after the block finishes running. Here another example of how to use block scope as defined within an if block. Here let's analyze this code. What we have here is a lock sky color, and inside this function we define dusk variable and set it to true, then define color and set it to blue. If dusk, let color, so here you see we have two different variables. The first one is color outside the if, and the second is the color inside the if. So after this block there is no color inside the if, and the color will be blue because after this line this variable will be removed from memory and this one remain here. But if we want to access the color outside the function block, we got reference error. Block scope is a powerful tool in JavaScript since it allows us to define variables with precision and not pollute the global scope. If a variable does not need to exist outside the block, it shouldn't. It's a simple rule. Exercise. Inside the function body of log visible light waves, beneath the region variables and before the provided console.log statement, create an if statement that checks if the region is the arc-thick. Let's copy this code here. Here we want to add an if statement and that check if the region is arc-thick. Great. Inside the if, I check the region is the arc-thick. Inside the if block, define a new let variable light waves and set it to northern light. Use let northern light. Beneath the variable in the if block, use console.log to log the value of the block variable inside the if block. Console.log. Run your code and notice the output. Run the code. You see northern light. It's the value of this variable, and moonlight is the value of this variable. Although both of them have same name, but inside the if it's a inner block and the value of light waves comes from the nearest variable, and after the if block there is no light wave, and what is remain is light wave in the function body. Let's review what we learned in the scope of JavaScript. In this lesson, you learn about the scope and how it impacts the accessibility of different variables. Let's review the following terms. Scope is the idea in programming that some variables are accessible or inaccessible from other part of the program. Blocks are statements that exist within a curly braces. Global scope refer to the context within which variables are accessible to every part of program. Global variables are variables that exist only within global scope. Global variables are variables that exist within global scope. Global scope refers to the context within which variables are accessible to every part of the program. Global scope variables are variables that exist within global scope. Block scope refers to the context within which variables that are accessible only within the block they are defined. Local variables are variables that exist within block scope. Global namespace is the space in our code that contains global scoped information, and scope pollution is when too many variables exist in a namespace or variable. That's all about scoping in JavaScript, and follow next tutorials on JavaScript, which is erase.